All right, my girls. So today we are going to talk about the different types of data that you can collect anytime you're doing any type of experiment. So your science fair project, labs that we do in here, we're always collecting data. So I just made a short presentation that kind of just goes over the different types you can get and kind of how we classify data, because that will help us to determine what we do with that data and how we will interpret the results of a project. So there are two broad categories or two main types of data, and those are qualitative data points and quantitative data points. So these two words, they look super similar, so quantitative and qualitative. But when you think of the word qualitative, you should look at that root and you should see quality in there, right? So the quality of something. A qualitative piece of data is going to tell you things that can't be measured with numbers, essentially. We use words whenever we're talking about qualitative data. So what color is something? What texture is it? Is it smooth? Is it rough? Is it in between? How attractive something is. It's very attractive. It's not attractive at all. There's a scale, right? Or levels of motivation, right? We might assign a number to that level, like, oh, I'm 1 out of 10 motivated to listen to this podcast, or I'm 10 out of 10 motivated to listen to it, right? But that's still not necessarily something you're measuring with numbers. You're just assigning a number to it. But qualitative data is stuff that you don't measure with like a ruler or a scale or a pulse oximeter like we did with a homeostasis lab. You don't use a tool to measure this. It's kind of something that you use your eyes or your senses to measure. Quantitative data is the data of numbers. Quantitative, you should see the root quantity in there. So quantity tells you about an amount. So this is for any data that you collect that you can measure, that you can use a ruler, or you can use a thermometer, or you can use a scale. Any of those things, you can actually get a number. So your height, obviously when you go to the doctor when you're younger, when you go to the pediatrician, they make you stand up against the wall so they can measure your height. The width of something, the length of something, how much something weighs, what the temperature is, even how humid it is outside, which honestly for Louisiana, it's almost always 100%. How much something's going to cost, how much space something is taking up, so the volume. Those are all things that we can measure with numbers. So that is quantitative data. Now, qualitative data and quantitative data are, again, the two broad categories, or the two main groups of data. But there are further subcategories of these two types. So let's kind of talk specifically about quantitative first. Personally, in my opinion, quantitative data is the easiest data to work with whenever you're trying to do your science fair projects. Because it's numbers, it's easy, you measure something, and then you can perform statistics, which I know we haven't talked a lot about statistics yet, but you're going to run a statistical test at the end of your project to see if your data actually means anything. So quantitative data is really easy to run statistics on. So for me personally, if I was going to pick a science fair project, I would pick something, which I have done, I would pick something that I can measure with numbers. However, you don't have to, but we'll talk about this one first. So we can subdivide quantitative data into continuous quantitative data and discrete quantitative data. In continuous, this is data basically that can use decimals. It can be made more precise, and I'll give some examples on the next slide. But a continuous data, oh, my dogs are growling. Let me pause it for a second and come back. Okay, so where I left off when the dogs were growling. So continuous data is anything that can be made more precise. You can kind of break it down and you can say like, oh, somebody weighs 123.6 pounds or 130.2 pounds or whatever it is. You can make it essentially just more and more and more precise. Typically that means decimals. If you can use decimals for the data, it's continuous. Like measuring height of a child, that's a good example. So over time, the child's going to grow. She'll be 2 feet, then she'll be 2.5 feet, and then she'll maybe be 2 feet 10 inches, 3 feet, 3 feet 6 inches. So it's continuous, right? Whereas discrete data, that's data that cannot be made more precise. You cannot divide these numbers. For example, the number of pets in a family. You can't have 1.5 dogs. Even though Magnolia is missing one of her legs, she's still a whole dog, right? So she's not like 1.5 of my pets, right? You can't half or quarter or anything the number of pets. You can't make more precise the number of children in a family. You can't say someone has like, oh, they have 3.5 kids. No, they either have 3 kids or they have 4 kids. They do not have 3.5 kids. So discrete data is data that literally you cannot divide or it's going to get really weird. So just some pictures for those of us out there that are visual learners. So let's say we were trying to figure out the weight of those jujube candies. I don't know if you've ever had them. They come in a green box. They're pretty disgusting, but for some reason one of my best friends loves them, so they're a good example to use. But if you were to weigh the jujubes on a scale, that's continuous, right? You can get a decimal number for exactly how much these things weigh. But the number of jujubes in the box, that's discrete. There's a set number, and you can't divide it, you can't make it smaller, it's a set number, so it's a discrete number. Okay, so that's quantitative data. It can be broken down again into continuous quantitative data or discrete quantitative data. Qualitative data can also be separated into its own smaller groups. Now, for qualitative data, I personally don't love qualitative data for a science fair project. You can do it. Do not get me wrong. You can do it. But it just makes it a little bit harder for you guys to do the math at the end, the statistics at the end, which don't worry, there's a person who will help you do the statistics. You're not just going to be thrown in blind and be like, all right, do all this fancy math. They're going to help you. But qualitative data can be broken down into 3 further categories. Binary, so placing things into 2 categories that are considered mutually exclusive. So it's either one or the other. Something is either right or it's wrong. It's black or it's white. It's good, it's bad. It's true, it's false. There's only 2 categories they can fall into. So bi means 2, so binary. It will either be good or it will be bad. There's no gray area in the middle. That's binary qualitative data. Nominal qualitative data is data that is unordered. So they don't have, so let's say you're trying to like assign something to a particular category, but that category doesn't have any like inherent value or in any type of like rank associated with it, right? So if you're trying to count like the number of each color jujube, like, okay, there's 5 purple, there's 10 green, there's 3 red, and there's 7 yellow, right? There's no rank for those colors. They're just colors. So that's nominal. You're giving it a name, but there's no inherent rank or value. Ordinal qualitative data is whenever you assign something to a category that does have an implicit value. So something being categorized as tall, medium, or short, or rank your enthusiasm about everyone coming back to school on a scale from 0 to 10, right? There's inherent rank in those numbers or in those categories. So if something's tall, well, you immediately think of things that are tall. If it's short, you immediately think of things that are short. While those values might be more defined based on whatever project you're doing, you're still going to have an inherent order to these things. So ordinal data is assigning things to categories that do have an order. You either really, really, really like something, so you give it a 10, or you really, really hate something, so you give it a 1, right? Depending on the scale that you use. So there is an inherent order with ordinal data. So again, why is this important? Why do we want to know about data? It's data that lets us know if our independent variable that we tested actually caused the difference, or was it just due to chance, right? So because you collect data, you can perform statistical tests on them, which are fancy math things that we'll talk more specifically about later in the year. But when you can run a statistical test on something, that statistical test will say, does my data tell me what I think it does? Because it might look to you like the difference between 3 and, I don't know, 3 and 10 is a big deal. But when you run the statistics on it, whatever statistics you're using might say, actually, that difference between 3 and 10 isn't really that significant because the other numbers you had were between 3 and 100. So between 3 and 100, that's a significant gap. But between 3 and 10 is not really significant. So you use statistics to actually tell you what your data is saying. It helps you have a definitive, clear-cut guideline that scientists use to say, okay, this data does tell me what I think it does. So I can either reject or fail to reject my null hypothesis based on what my statistical test tells me. So did my independent variable make a difference or did it not? So that was kind of like the example in the scientific method notes that y'all read yesterday that were like saying if a kid takes vitamins and they grow or if they don't take vitamins, right? Well, do you know that the child grew because they took vitamins, or were they just going to grow anyway, whether they took vitamins or not? That is what a statistical analysis tells you. It did or it didn't grow. Or your data tells you either your independent variable did have an effect or it did not. So you need your statistical analyses to tell you that, and you can't do statistics without collecting data. And that is all I have for you. So yay, I will see you guys all on Monday.